Hi everyone! Today's lesson is about a topic called balancing chemical reactions. And so the goal for this lesson is that you know how and when to balance a chemical reaction. So you've been working and looking at chemical reactions a lot in the last few weeks as you've been learning about acids and bases. So I first want to rewind and make sure everyone remembers what a chemical reaction is. A chemical reaction is any time that the molecular structure of a substance changes. So, for example, if I have a pot of water and I stick it on the stove and I allow that water to boil, that is not a chemical reaction. The reason for that is that the water is H2O, but the steam is also H2O. And so in order to have a chemical reaction, chemical bonds need to be broken or new chemical bonds need to be formed. So we're breaking down molecules and making new ones. And that's what a chemical reaction is. And the way we write a chemical reaction, you can see right here, is we write the compounds that are reacting. Those are called the reactants. I like to think of them as the ingredients, just like you're cooking. The arrow means a chemical reaction is happening here, and then at the end, that's what you're left with. That's what was produced. So we call those the products. Okay, so let's take a look at this chemical reaction. This chemical reaction tells us that when we take a molecule of hydrogen, and H2 is covalently bonded, so it looks like that, and when we combine it with a molecule of chlorine, with two chlorine atoms joined by a covalent bond, what we get is HCl, which you guys all know is hydrochloric acid. So that's what this reaction is telling us. It's telling us we mix hydrogen and we mix chlorine and we get hydrochloric acid. But there's a big problem with the way this chemical reaction is written. See if you can find it. So the problem is that we have two hydrogens in the reactants, but only one in the products. And again, we have two chlorines in the reactants, but only one in the products. And that's a problem because where did the other hydrogen go? Where did the other chlorine go? They can't just disappear. And so with that, I'm going to introduce a very important concept in chemistry, and it's called the law of conservation of matter. It's exactly what it sounds like. So law basically means it's a rule. To conserve means to keep, not to lose. So if you're conserving energy, you're trying to hold on to your energy. So the law of conservation of matter means that in any kind of chemical reaction, or really any situation, matter means atoms, elements, and molecules, cannot be created or destroyed. Okay? So I can't just destroy one of the hydrogens and one of the chlorines in this reaction. Right? They have to go somewhere. And so what we need to do is something called balance the reaction. And that's the big learning for today's lesson, is how to balance a reaction. So we can't change this molecule. I can't all of a sudden call it H2Cl2 because that's a different compound. It's not the same thing. But what we can do is add coefficients. So what I'm going to have you do right now, I want you to rewrite the chemical reaction. Right? So it's the same one, but you're leaving a space in front of each molecule. Right? So you're just writing in a blank space, and we're going to use those spaces to put in coefficients. So when I say add coefficients, that should make you think of algebra, and it's just like algebra. In algebra, I can write 2x. 2 is a coefficient, and that means I have two x's. So let me show you how we add coefficients to balance a chemical reaction. So I've got a table here. In that table, and this is the table you're going to make every time you balance a chemical reaction, I've got one column for the reactants and a different column for the products. And then I have to make a row for each element that's in the reaction. So in this reaction I only have two elements, hydrogen and chlorine. So now what I do is I count how many hydrogens are in the reactants. Remember, the reactants is the front half of the equation. I have two hydrogens in the reactants. Chlorine, I have two chlorines in the reactants. Okay, in the products, I only have one hydrogen, and I only have one chlorine, right? So that's part of the problem. I need more hydrogens and more chlorines in the products. So I can put a 2 in front of HCl. 2 is a coefficient. And what it means is that if I combine one molecule of H2 with one molecule of Cl2, I'm going to get 2 molecules of HCl. Now, why did I choose a 2 and why did I put it there? Because I realized that if I put a 2 here, then that means now instead of having one hydrogen in the products, I have 2, because it's just like algebra. 2 in front of an x means 2 times x. 2 in front of the H means 2 times H. And it also means I have 2 chlorines. So now everything balances. And I've got a little picture to show you this another way. So again, if I have a molecule of H2, which you see right here, and a molecule of Cl2, which you see right here, that's going to give me 2 molecules, here's my coefficient, of HCl. Okay? And the reason for that is the law of conservation of matter. The atoms can't just disappear. They can't be destroyed. So because there are 2 hydrogens and 2 chlorines to begin with, I'm going to end up producing 2 molecules of HCl. So now I'm just going to go through another example with you. So here I have another chemical reaction. I have NaCl plus MgO creates MgCl2 and Na2O. So I want you to pause the video for a moment and make sure you copy down this table properly. Reactants. So NaCl and MgO are my reactants. And then products are MgCl2 and Na2O. Okay? The reactants, those are my ingredients that went into the chemical reaction. The products are what were produced. So again, I'm going to start by counting how many of each element, this time there are 4 elements, I have in the reactants and how many I have in the products. Okay, so in the reactants, I have 1 of everything. I have 1 sodium, 1 chlorine, 1 magnesium, and 1 oxygen. Now I go over to the products. I have 1 magnesium, 2 chlorine, magnesium's down here. I have 1 magnesium, 2 chlorine, 2 sodium, and 1 oxygen. So I have to look at my table now and say, where are the problems? Magnesium's fine, oxygen is fine, right? 1 on each side, that balances. Nothing's being created, nothing's being destroyed. Sodium, however, is a problem. I can't have 1 sodium on this side and 2 on this side, because remember, we can't create matter, right? We can only have it react and form new chemicals. So somehow I need to find a way to get 2 atoms of sodium in the reactants. Now I can't change the molecule. That means I can't add little numbers, because that means it's a whole different compound. All I can do is add a coefficient. So let me try putting a 2 in front of NaCl. Well, that gives me 2 sodiums, which makes everything good. And it also gives me 2 chlorine atoms. and that means everything is good too. Now if I go through 2 and 2, 2 and 2, 1 and 1, 1 and 1. Okay? So, it's okay if you don't have this mastered yet. You're going to do lots of practice in class. But here's what you need to leave this video understanding. You need to know what the law of conservation of matter is. You need to know why we need to balance chemical reactions. And you need to be familiar with the process, right? And by that I mean you need to know that you have to rewrite the chemical reaction with spaces in front. You have to make a table, list all the elements, and then how many of each element are in the reactants and the products. And then it's sort of a game of trial and error, trying different coefficients in different places until all of the elements balance out. And that is it for today's lesson. You will get lots more practice in class, but post to the chat room if you have any questions.